All right, class, this is chapter 11 and lesson 11.1, and this chapter deals with trig identities, and we're going to start off the chapter with the law of cosines. So last chapter we dealt with right triangle trigonometry, right triangle trig. And what is right triangle trig? It's the trigonometry involving right triangles, and we learned the sine and cosine and tangent, understood those ratios, and dealt with a right triangle. This chapter, instead of dealing with a right triangle, we're going to deal with oblique triangles. Oblique triangles. And what are they? Nothing more than non-right triangles. Okay, non-right triangles. Now, we learned how to figure out sides of triangles and angles of triangles using our trig functions, and that works great for right triangles. Now we'll deal with non-right triangles. We've got to come up with another methodology. And the first method we're going to learn is the law of sines. And the law of sines is a proportion. And so it's a set of ratios. And so let's go ahead and fill in the formula, and then I'll go ahead and explain it. Oh, by the way, if you don't have a calculator right with you right now, go ahead and pause the video. Make sure you grab one. You're definitely going to need your calculator. A big part of this lesson is learning how to punch in the data correctly into your calculator to get the correct answer. So really, really important that you have your scientific calculator with you as you go through this lesson. All right, here's the formula. It's pretty simplistic. Just like last chapter, any lowercase letter represents a side of a triangle. So A is side A of a triangle, B is side B of a triangle. And just like last chapter, what comes after the trig function is the measure of an angle. So capital C there is the measure of angle C. Okay, so how do the ratios go? Side A over sine A. Side A over sine of angle A. Makes sense then. The next one would be side B over sine B. Side B over sine B. And then the third one, side C over sine C. So how do you use the formula? Oh, you simply use two at a time. Maybe you're going to use these two proportions as your formula. Maybe you're going to use these two proportions as your formula. Maybe you're going to use this one equaling that one as your formula. And the other thing that you can do is you can use the reciprocals. So you can put the sine A on the top and A on the bottom. Just remember, if you do that for one, you've got to do it for the other. Okay? So you can flip them upside down, and you'll see that here as we go through in just a moment and work some problems. But you got to know the formula. Law of sines is pretty easy. Again, side A over sine A, side B over sine B equals side C over sine C. And we'll pick the two of them that will allow us to have just one variable and solve. All right? So let's go through and do some examples. All right, so B here is when knowing two angles and a side, and this says find side A. All right, well, let me just mention for a moment this notation. AAS should be familiar with some of the aspects of geometry last year. Last year, when you were trying to prove two triangles to be congruent, you had some postulates and theorems. And they involved SSS, side, side, side. When basically if three sides of one triangle are congruent to corresponding three sides of another triangle, then the two triangles are congruent. You had side, angle, side. If two sides in the included angle of one triangle are congruent to the two sides in included angle of the second triangle, then two triangles are congruent, etc., etc., etc. You had angle, angle, side, and others. All right, angle, side, angle. So this is not to prove two triangles congruent, not at all. As a matter of fact, we only have one triangle. It is simply showing you what you're given. You're given an angle, you're given another angle, and then a side that's not between those two angles. I'm sorry, over here, side that's not between those two angles. So angle, angle, side. So that's the condition. When you have angle, angle, side, you can use the law of sines. And you can use that then to find a value. All right, so let's go through All right, if you remember, for me, I said whenever you set up a proportion, it's best and easiest if you put what you're looking for, the variable, in the top left. So I'm going to put A in the top left. All right, just to be clear on the formula, the bottom has to be sine of angle A, has to be. And now, which proportion or which ratio am I going to use to finish the proportion? Well, remember, I have two choices. If you look at the formula, I can use this one or I can use this one. However, in reality, I'll only be able to use one of them. And I simply have to look at my triangle and decide, do I know side B and the angle B? If I do, I'll use it. Or is it I know side C and the angle of C, then I'll use it. So it takes looking at my triangle, and I look and see and understand, okay, there's angle B, and there is side B. Therefore, I'm going to choose side B over the sine of angle B. All right? So again, it depends upon what you're given, what you're going to use there. Okay, let's go ahead now and substitute in the data. So remember, what comes after the trig function is the measure of the angle. How many degrees is angle A? It's 20. All right, so that is there. And then we're going to do side B is 7. And then the angle will be the sine of 28 degrees. Okay, so you remember we learned things in the bottom go to the top across the equal sign. And again, how does that happen? I mean, technically, you're multiplying both sides by the sine 20 degrees, right? Those would cross out, and that's how you get there. That's all we're doing. But again, shortcut, things in the bottom go to the top, cross equal sign. All right, so what we need to do now is we need to make sure that we can understand the syntax of our calculator and how to punch in this data to get the correct answer. I will tell you this, looking at the triangle, I'm expecting a value here. I'm trying to find A. Triangles aren't always drawn to scale, but they'll give you a general idea. So I'm looking for a value somewhere between 7 and 5, perhaps, should be the value of A, looking at that. Okay, so you're going to punch in the data here. 7 times the sine of 20 degrees divided by the sine of 28. And again, it's key that you understand how to punch that in. So pause the video if you need to. Go ahead and get those values, and we'll see if you're able to come up with the correct value. All right, I'm punching it in right now myself, and I got 5.1, and that is in the range that I was expecting, and I feel confident with that answer. All right, side A is 5.1. Okay, so again, if you can't get it yet, pause the video. Remember, what are you doing? You're multiplying 7 times the sine of 20. Now remember, you can't go 7 times 20 and hit the sine button. Sine 20 is its own entity. So 7 times the sine of 20, then that quantity has to be divided by the sine of 28 degrees. All right, keep playing with it until you get it. Let's go to the second example here. Okay, in this example, we're asked to find angle A. So in this one, we're given side-side angle. And so again, if you look at the triangle here, here's a side, and the angle comes after the sides, meaning it's not included. It's not between the two sides, and it's not. So that's the scenario, side-side angle, and we're going to try to find angle A. All right. So again, how am I going to choose my proportion? I'm always going to put what I'm looking for in the top left. So I'm going to do sine angle A. Then, therefore, I must put side A below it. Now again, I need to decide which of the other two ratios am I going to use. It's going to be based upon what I'm given. So again, I go and look at what I'm given. Oh, I'm given angle B, and I'm given side B. Therefore, then, I'm going to choose the B functions. Now, Because the sine A is in the top, I need sine angle B in the top. And it's going to be divided by B. All right, so really what we've done is now we've flipped up both ratios. But again, always what I'm looking for is in the top left, and when I do that, it makes solving the equation a whole lot more simplistic, and it just makes it an easy thing to do. All right, let's go ahead and sub in the data. So sine A remains sine A. Side A, remember, is opposite angle A, so that's the 5.1. Sine B is the sine of 28 degrees, and side B is 7. All right, just like before, things in the bottom go to the top across the equal sign. Be careful here. Remember, trig functions are a quantity. If you tried to punch in sine, then 28 times 5.1, your calculator might think that it's 28 degrees times 5.1 and then take the sine. You don't want to do that. You need to do sine 28, enter that, finish that out, then multiply that result times 5.1, divide by 7. However, one other word of note here. Remember, with our calculator, it is the -1 buttons that give us the angles. So really, to finish this out, remember the measure of angle A is going to be sine to the -1 of what's up above, right? And just for clarity's sake, I'll just rewrite it here. Sine 28 degrees times 5.1. Again, I'm going to put that in a parentheses, divided by 7. Okay, go ahead and punch that in and see if you're able to get a correct answer. You can pause the video if you'd like. If not, you're going to hear the answer here in just a second. But go ahead and punch that in and see if you're able to get the correct value. And I got 20.0 degrees. Hey, we're rounding to 1 decimal point, so I'm going to include that 0.0. All right, 20.0. Hopefully you got that. If not, keep playing with your calculator. By the way, if you'll notice, I used the same triangle 2 times. And surely A is 20 degrees, and we just found it by using the law of sines. And that's the reality, all right? So normally you wouldn't have a situation where you're going to find something you already know. I just wanted to prove to you that the formula works, and indeed you get the correct solution as long as you set it up correctly and as long as you punch it in correctly. All right, let's get to our third example here on the page. All right, so example number 3. All right, here we go. When given 2 angles and the included side. Okay, so this time it's angle, side, angle. So let me illustrate that for you again. You have an angle, the included side, and another angle, right? An angle, the included side, and another angle. Angle, side, angle. In this situation, we want to solve for side C. All right, so how are you going to set up your proportion? Again, if you want to do it all on your own, pause the video, go ahead and work through it, and then start the video back up, and you'll see if you're correct in your figuring. All right, I'm going to put side C on the top. Always what I'm looking for. Has to go under sine C. And again, I got to look and see, what data do I know? What do I know? Okay, in this situation, it appears like I don't have enough data. However, remember the 3 angles of a triangle equal 180 degrees. Side C is 132 and angle C is 132 and angle B is 28. That gives me 160. Therefore, angle A has to be 20 degrees. Okay? Now that you had to figure out. So that allows me then to finish the proportion with side A over the sine of angle A. There's my proportion. I'm going to go ahead and solve this to the left here for room's sake. Angle C is 132 degrees equals side A 5.1 over the sine of angle A 20 degrees. bottom, go to the top, across the equal sign. Okay, so there we are. I'm going to punch that in and see where we end up. And I got 11.1. 11.1. Okay, 11.1. And that makes sense. That's the longest side. We had a 7 of 5.1. 11.1 makes sense to me. And so 11.1 for that value. Okay? All right, again, if you were not able to get that, make sure you play around with your calculator long enough to where you figure out how to input it and get those values. Let's go to our second page here. All right, so here's a situation where it says solve triangle XYZ. All right, you have to remember, we did this last chapter, to solve a triangle means find all angles and all sides. Find all angles and all sides. So that's what you're after when you are solving a triangle. Each triangle is unique. You have to look at it and determine what to do. First off, let me give you a warning. Some students will see 15 and 12 and say, oh, I can use the Pythagorean theorem to find this side. No, you can't. No, you can't. Why not? Well, remember, we're doing oblique triangles. The Pythagorean theorem is for a right triangle. We don't have a right triangle. You cannot use the Pythagorean theorem. Do not make that mistake. That would not be wise. All right, so what I'm going to do is I'm going to look at this and see what I have and what I can find. Okay, I have this angle and I have its opposite side. So I have that ratio. I have this side, therefore I can find this angle using the law of sines, and that's what I'm going to do. So I'm going to set up my proportion. Again, I always like to put what I'm looking for in the top left. So that would be the sine of angle Z. Below it will go the value of side Z, which is 15. Up above now is going to be the angle I know with the side that I know, so therefore it's going to be the sine of angle X, and it's 42 degrees, so I'm going to put that in there, over side X, and that is 12, and there's your proportion. All right, so let me go over that again for you. I'm going to start with what I'm looking for, the sine of Z. Therefore, the bottom must be the side opposite that angle. What side is opposite angle Z? It is the 15. Okay, so we're set there. Then I'm going to look and say, what angle do I know with what side do I know? And again, I know angle X, and I know its opposite side, 12. Therefore, I'm going to choose that. Now, what goes on the top? Well, I have the sine function in the top on the left. I need the sine function on the top on the right. That's pretty simplistic. All right, and then how many degrees? 42, so sine 42. And then you're looking at the side opposite the angle on the bottom, and that's 12. There you go. All right, again, if you want to finish from here, pause the video. If not, here goes the answer again. 15 goes to the top across the equal sign. Hey, you can put that in the front if you want, or in the back. In the front might be safer, so you're not tempted to multiply the 42 times the 15. All right, let's punch this in and see where we end up. Oh, one other reminder, of course, and by the way, let your calculator be your guide. Remember, the measure of angle Z is sine to the -1 of this value, right? So make sure you're doing sine to the -1 because we're looking for an angle. And the measure of angle Z, according to my calculator, is 56.8 degrees. 56.8 degrees. I now have the measure of angle Z. All right, with knowing two angles, most will get the third angle by saying the sum of any three angles of a triangle are 180. This means we've got to get angle Z correct, but usually for time's sake, we're going to trust that we did. All right, usually don't like to use your own data to get another piece of data, but in reality, that's what we're going to do here. Okay, so because we know Z is 56.8 and we know X is 42, so I'm going to say the measure of angle Y is simply 180 minus 42 minus 56.8 degrees, right? I mean, that's all you're going to do. So punch that in. And I got 81.2 degrees for the measure of angle Y. Okay, so we've gotten all the angles. The last thing left is side little y. All right, so again, my choice here is going to be the law of sines. I'm going to put what I'm looking for in the top left. Side y goes over the sine of angle y, 81.2. We've got to use what we found. There's no other way. And then two things that I know, I definitely know side x and angle x. So I'm going to go side x 12 over the sine of x, sine of 42. Again, because I started with the sine on the top over the trig function angle, the other proportion has to follow suit, right? The other has to follow suit. Okay, things in the bottom go to the top across the equal sign of proportions. And so we're just going to punch that out and see where we end up. And again, always you want to ask the mams. Once you're done, does my answer make sense? And here I'm getting y equals 17.7. Again, not all triangles are drawn to scale, and that doesn't look to scale at all, but that's a viable answer, and we're going to trust that it is correct. Okay? That's the process, and that's how you're going to go about it. Okay? So let the data take care of everything, and away you go. All right, let's do another one. My advice on number 3 is to pause the video and go ahead and work the problem, and then start the video up to see if you were correct in what you were figuring out. Okay, that's my advice. So you should pause it now because I'm getting ready to explain the solution here. All right, solve the triangle. I've got to find all angles and all sides. This one, it's easiest to go ahead and get the third angle right away. We're given two of them here. So we're just simply going to do 180 minus 40 minus 98, and we are going to end up with a 42-degree angle. Okay, it's a measure of angle P. That was easy. And that's one piece of data that I need. All right, now I'm going to look and decide what side to go for. I'm going to go for side little g first. Doesn't really matter which way you go. That's the way I'm going to go. How am I going to do with proportion? Again, me, put what I'm looking for in the top left. That's going to go underneath the sine of the angle opposite side g, so that's 40 degrees. And what do I know? I know the 30 meters, and the 30 meters goes with what angle? The sine of 98 degrees. By the way, notice I put my units here. Help me to remember to put an answer in meters. Okay, things in the bottom go to the top across the equal sign. Again, I'm looking for a side here, so I'm just punching in values. Sine of 40 times 30. I'm going to divide that result by the sine of 98 degrees. And I got 19.5. 19.5 for side G. Looks like a Y there. 19.5. Okay? All right, I trust that that's a good answer, and I now have to find side P here. Again, law of sines. You can't use the Pythagorean theorem. We don't have a right triangle. We've got to use proportions. All right, so to get our last piece of data, one more proportion. What I'm looking for, I always put in the top left. It's going to have to go over the sine of angle P, 42 degrees, equals, and again, I'm going to use the 2 that it gave me. It's just safer. 30 meters divided by the sine of 98 degrees. Things in the bottom go to the top across the equal sign. All right, we're going to punch this out and hopefully get the value of side P. All right. Again, you're just punching this out in your calculator. Again, be careful that you learn your calculator. Once you're done, ask the ma'ams, does my answer make sense? And hopefully it does. And I got 19.5. Wow, that shouldn't have happened. Let's make sure. Oh, because look at that. We have 42 and 40. This is 42. See, the ma'ams didn't like that answer. And I thought, nah, how are these sides the same? No, what did I do? I wrote 40 instead of 42. So always ask the ma'ams. 30 divided by the sine of 98. And now I get 20.3. And look what else I just caught. My meters. And because I caught it here, I'm going to go back and stick it in there. Include your units. It'll help you out with those little details. Okay, we solved the triangle. We have all 3 angles and we have all 3 sides. And away we go. All right? So hopefully you've got some examples there. Look, you can come back and view this video as many times as you want to try to get these procedures down. All right, that's the idea of the law of sines. Remember, it's for oblique triangles, non-right triangles. If it were a right triangle, we just use right triangle trig. Use the sine opposite over hypotenuse or the cosine, the adjacent over the hypotenuse or the tangent opposite over the adjacent. Can't do that because we have oblique triangles, and therefore we will use the law of sines. So make sure that you know the formula. It's not hard, pretty simplistic, but make sure you know it. All right, let's finish up this last aspect here. So how do you know when to use the law of sines? How do you know when to use it? You look at a problem, all right? Well, it's an oblique triangle. In other words, it's not a right triangle. And you have enough information to use it. You have enough information to use it. All right? Hey, it's not a right triangle. You got to use the law of sines, or number 5, tomorrow's lesson, or the next time we meet lesson, and that is if you can't use the law of sines, you're going to use the law of cosines, and that's coming the next time we meet. Okay, so when do you use the law of sines? Hey, when you got enough information to use it. And we'll talk next lesson. Usually you'll either be able to use the law of sines or the law of cosines. Sometimes you could use either one. You know what? When you have a choice, use the law of sines. It's a little bit more simplistic of the methods. All right, that's the lesson. I've got the homework listed there, but that's only if for some reason you're not able to make it in the class on Tuesday. Because we flipped our class, you watch the video for homework, and you will do the homework in class on Tuesday. All right, so 446 is not assigned yet. It's Tuesday's assignment that will be due on Wednesday next week. All right, enjoy your break.